Hello again. So here is the slides. Oops. Oh, it's a local host. 8.4. Why I couldn't see the slide in web? Which web? You see, it's right here. What are you talking about? So today we are going to talk about our relationship. Learning control, I don't know. I'm going to copy this one. Oh shit. Thursday. It's here. What are you talking about, Kan? Oh, you don't see the link to the slides, you mean? Alright, here's the slide. You can take a look at this. Shit, it's gone again. Slides or code school. Alright, first thing first, I know this week was very tough, and I heard that people complain a lot about this, and yeah, I know, because we learned about database, which is very hard. Also, we also learned the syntax for OOP, we also learned the syntax for Mongoose, and middlewares for Mongoose. Those kind of things are like very hard at first. But we know, and I know, you know, everyone knows that, right? You know your classmates are like struggling, but just hang there. Like, the bootcamp is supposed to be very tough, and you need to survive this in order to be like successful. And normally people who survive this kind of like bootcamp, they tend to be very independent, and they like 80 or 90% they will be successful in their workplace or something. So imagine that if you go to work, right? Your boss doesn't like give you a very detailed instruction. Instead, they will just tell you to do this, do that, and if you don't know how to do this, go read the docs, go read the instruction there, just something like that. And you need to be like independent in order to survive in your workplace. It's the same thing here. Bootcamp is like to prepare you everything for that kind of work, right? Experience, the skills, everything. So it's very tough, and we try to make it step by step, so that you can you have the experience of learning and working at the same time. And we try our best. You try your best, we know. And so just hang there. We are almost done. We are like 2 more weeks, but this week we are gonna finish the basic knowledge about the model, which is very important. We know about the controller, like half of controller. We also know the model, and this week is today is the last topic about model. We also know how to work with the views or the view engine, right? We can do it server side or we can do it client side. We know everything now. Next week or the weeks after that, we will learn some additional feature, for example, socket IO, and how to add more smaller features, for example, the geolocation, and how to upload to a third-party website, or how to implement the social login. Those kind of things are just additionals. So this week is very important, and if we have time, or if we have one more spare week, we can have more practice on this kind of topic on the model. Model is very important. So I would like you to go back to your last week assignments and add the model to your assignment, to the project. Right? It's a good practice. So let's recap a little bit. Yesterday we learned about user authentications. What we learned is the flows. The flow is very important. Can anyone here like explain what happened in the user authentication? It's just theory, just step by step. What happened like when the user log in, and how do they transfer or receive some data when they send a GET request to a protected route. Question first. I heard that after week 10 we will have more 2 more weeks to study, and about that I'm not so sure. It would be like if we had 2 more weeks just to study. I think that's too long. That's too long because we already have 1 week of recap for React for the front end already, and we will have 1 more week for the back end as well if you want, and then we will have 2 weeks for the final project. The idea of the final project is not just about how good you are, you can make it, you can build it. It's all about the time management, right? Project time management. So that's why we decide to make it 2 weeks, not 3 weeks, or not 1 week, or not 1 month, or not a year, right? You can build a very beautiful application in 1 year, but we want you to make it in 2 weeks to see how far you can go. We don't want you to make a perfect application. So it is the same in your work place. For example, your boss is gonna ask you to build an app in 1 month, for example. There's a lot of things you have to think about how good you want to make it, right? I know the extra work for the backend file once we come back to the office. Yes. So it's not about how the time. So the require are strict to pass. Any news of the shit, I'm recording, and this shouldn't be in the recording, but anyway, the official statement from the government is like the social distance is like stop from today, and business can resume works on Monday, but still public gathering is like still prohibited. Like you cannot gather too many people in one place. And about education or stuff, we haven't heard anything about that yet. But yeah, so we are not allowed to gather so many people in one place. So yeah, so that's a small update. Yep. School are still say in the middle of May. We will resume in the middle of May. School is for education. School for high school, middle school, something like that. So we haven't heard anything yet. Right, and so let's go back to the let's go back to the topic here, guys. This topic is very important, and it's very exciting as well. The syntax is hard, though. I would say the syntax, the code is hard, but the flow here, actually not the flow, but the theory is kind of like okay. So here, let's take a couple of minutes to recap. Can anyone explain me the user authentication flow? Joris wasn't here yesterday, so I'm gonna ask a different person. How about Khoi? I just saw you chat. Khoi.
For the user authentication flow, I assume that from the client, you need to send a request to the website or the server. And then on the application side, you have middleware that intercepts your request. And the middleware walks it through some authentication or some database calls to the model, right? So it makes some, once it authenticates you, it could make some calls to your remote database, and then it which is stateless, and then it returns whatever information is necessary in the response. So that's the typical flow. But for the specific user authentication flow itself, I think it's I believe you use middleware to well, you let's say you have an email and password request. It checks that to your database, right? And then if it's correct, and the middleware will give you a token, the response, which the client stores. And then once you have that token, that authentication token, it can be used for all future like get, post, whatever request you need. And then the flow then is that it just checks the token against your existing tokens for people who are logged in. So yeah.
Perfect. Correct. Thank you. Does anyone have any question about this flow? Any like step you're not clear yet? It's very important to have a good understanding of the flow here. No, the flow is kind of easy, right? But the implementation is hard. It's not that hard. Why is modified weird? Why is that weird? That's not weird. That's not weird at all. It's because we have a middleware called resave, a rehook, resave. That's why we need to check. It's kind of like we have to check if that field is modified or not. If it's modified, we will hash again. If it's not modified, we will not hash. It's can return true, but after you hash it, it will transform. What? Alright. Because the first time you make an account, we start from undefined or no, right? And then we give some value. That means we modify that field. It starts from nothing to some password, for example, 1, 2, 3, 4, 5. That means that field is modified. But the next time we, for example, we log in, we actually haven't or don't modify anything. We just send a token in order to not token, a password from the client to check, to compare with the original password. That means we don't modify anything. We just comparing, right? And that means we is modified, then will be false. And when it's false, we're not like hash again. That's the whole reason. Alright. Okay, I think I explained that a couple of times already. Like yesterday, like 4 or 5 people asked me about this question at night. It's okay. It's good if you ask questions like that. And alright, I'm gonna move on to the next thing. We store and use credential. Can anyone explain why we need to hash the password before we store it? It's very easy. This is easy. So you asked this question. Okay, I'm gonna ask you again back. Why do we have to hash the password before we save it? Yes. Increase security. Can you be more like specific? Everyone has to look at the chat. I wish there's a status slide like Win is typing or something. Are you typing? Something like, yeah, I wish I see something like that. Right, Jared's answer is very Jared's answer is perfect. Like, it's right on the spot. We don't keep the original password, right? We just don't keep the original password. That's it. That's pretty much it. That's the reason. uh, and why don't we want to keep the original password is because the database can be leaked, right? Many people have access to the database, not just me or you, maybe other employees, other chat supporter, or other like maintainer. So we don't want them to see the password of our users. That's why we need to hash. Okay. Just like imagine how Facebook data was like they was leaked, right? But you cannot see their password. You can only see the information, the user information, for example, address, phone number, but you cannot see their password. You can only see a special string. That's why we need to hash the password to increase security. Yes. Yes, yeah, of course. It cannot be reversed. Right. Next, this one, Khoi already explained it. Answer it. How do we protect the routes? Basically, we will have a middleware for every protected route to check the tokens, right? That's it. Khoi already answered it. And debugging, what does it mean here? Yesterday, because the lecture was very long and very complicated, and it involved a lot of coding, so I make a couple of mistakes, and you can see on purpose or by accident. You actually see how I debug it, right? We have to check the stacks. For example, you will see there are two types of errors. The first type is like you don't see any message at all, and you have to figure out on your own what happened. Why don't we see the expected results, right? You have to trace back. It's called tracing. The other error is like you actually see it on the console log, not console, on the terminal or on the logs. You see the error names, error type, error name, and where's error come from, right? Coming from. For example, you will see a stack. It's very hard to produce error, but right. I already debugged for a couple of you guys, and I explained where it will go wrong. So basically you see a stack, and you have to trace back line by line. My tip is like you need to read the first line first, read the first line, the error type, and the error message, and then you will like trace back from the bottom to the top to see exactly where it fails, right? For example, if you see some file that you are not so familiar with, just skip it until you see something that you are familiar, like something you actually created yourself, and that's where the error comes from. Basically, it's very like rare. It's like 99% of the time that the errors come from your code, not the library, right? So if it's something wrong, that means your code is wrong. Most likely your code is wrong, and you need to look at the files that you created, not the file in the library, right? So if we talk about debugging, there's a whole lot of things to talk about. So that's my tip. Okay, so today's topic, relationships, especially in NoSQL or MongoDB. MongoDB is very famous. It takes like 80% of NoSQL. There are a couple of more database systems for NoSQL, but MongoDB is like so famous and widely used. 80 or 90% of the users. So we are mainly talk about MongoDB. And if you want to read a document about NoSQL, you can go to MongoDB, because MongoDB cover almost every cases. So go to the MongoDB website to read the documentation. For now, I still read the documentation on MongoDB a lot, because there's so many things to read and to remember. So basically, relationship is how the different documents are logically related to each other. Basically, how is this document related to that document? And that is relationship. Very simple, right? It's English, right? So let's take a 1 minute and look at your bookkeeping app and see. Can you tell me what are the relationships in your database? We have author, collection. We have user collection, we have genre collection, we have book collections, right? So please tell me the relationship between those collections, or to be more precise, those documents in the collections. Genre is part books. Yes. You just type it. You don't have to say anything. I'm not asking one person or two person. I'm asking the whole class. You can type it. Genre is part of the books. User make the books with text elements. That's too long, me. Yes. Yes. Right. So we have here's the relationship between those things. So books, we have relationship between books with genres, just like how Judith said, right? And we also have the books with the authors. Cool. Books with genre, like a book can have multiple genres, or a genre can have multiple books, right? We also have a books will have one author. It's not wrong, but it's too long. Right. And alright. Books with owners, or you can say user. So these are the relationships. There's no relationship between genres and author, right? No direct relationship at all. Genres and owner, there's no relationship between genre and owners. We only have relationship between books and genre, books and author, books and owners. So that those are relationships. And actually we have two ways to model those relationships. Oh shit, I just add this one back. Right, sorry. We have two ways to model the relationship in our database, but let's talk about the relationship type first. For example, we have these main three types here, and these relationship types only also like it's also applicable to SQL database as well, like for my MySQL or Postgres. So these are very common terms or very common knowledge, so you need to understand it. We have one-to-one relationship. For example, a user have contact info, right? Contact info can be a separate collections. User will be a separate collections, and one user should have one contact information. Also, one contact information can only belong to one user, right? So that's a one-to-one relationship. There are reasons why we want to keep them separate. So there are many reasons to keep them separate. We don't want the contact info to be inside the user document at all. We don't want, for some reason, we don't want that. That's a one-on-one. It's very clear. And here's the most popular relationship, one-to-many, or you can say many-to-one. It doesn't matter. So one-to-many is a book have an owner. Okay, this is okay. This one is many-to-one, and this one is to one-to-many. So one-to-many, we can, for example, here is owner and book. One owner can have many books, right? From yesterday project, one owner can have many books. As well, on the other hand, many books, one book can only belong to book to owner is a, yeah, we're not talking about one documents. We are talking about multiple documents at the same time. So one owner can have many books. One owner can have many books. And I'm confused now. This type shit is very hard. Okay, and many books can belong to one user, right? Many books can belong to one user. Inside that collection, many books can belong to one user, one owner, the other way. So this one is not so complicated, but we're gonna use this one a lot. One-to-many, basically one-to-many. For another example is like how do I say? For example, a user, right? A user have many shipping address. For example, a user can have many shipping address. If you take a look at the tiki.vn or Amazon.com, right? You have an account, and that account can have multiple shipping address. That means one too many, right? The third type is many too many. Basically, it's just a, you can say it's a one too many two-way, like a combination between two one too manys. Or you can say many too many. It's like genre and books. One book can have many genres, and one genre can have many books. And here's how we I describe more about one too many. This, because this one too many is very important. So I have a more specific explanation or a more specific understanding about one too many here. This is my own tip. For one too many, we will have two smaller types. You can have one to just a few, or we can have one to many, and we can have one to a ton. What does it mean? One to a few, for example, one user can only have a couple of addresses, right, in your database. You can like have one user have 100 address. It doesn't make sense, right? So one to a few, one user have a couple of addresses, or one user have a like 2 or 3 mobile phone numbers only. And one too many is like one user can have a bunch of blogs, can write a bunch of blogs, or a user can have a bunch of books, right? Oh, go back to one to few here. One to few here is books can only have a couple of genres only, right? You cannot have like 100 genres in just one book. It doesn't make sense. And one too many is more like that. It can be 1 to 100, or 1 to 1,000,000, or 1 to 10 million. It doesn't matter, as long as we know the limits. We understand the limits of how many documents that user have, like how many blocks that one user can have. Possible one user can have at most 1,000,000 blocks, right? That's too much already. So one user can have like 1,000 videos on YouTube. So that is one too many. So you know the limit. You know it's 100 or 1,000 or millions. As long as you know the limits. And the third one is 1 to a ton. When I use the word ton here, it's like you don't know how much document it is, right? For example, your application, when you open your console log, or you go to Heroku, right? You can see the logs for your application, and those kind of logs are actually stored somewhere. They are stored somewhere. And whenever you send just one request to your server, the server will do multiple things in order to send a response. So those type of things, those type of steps will go into the logs, and you will like have unlimited results. The logs, right? What are logs? Logs is like, for example, when you do Heroku logs tail, right? You will see the logs of the server. So basically, it say what the hell is going on your server side. So for example, who's connecting, who's sending a request, and what kind of request it is, and what's inside the request. Those kind of information are called logs, right? So for example, when we chat here, we can call it a chat log, and the chat log can be like, it can grow to like unlimited amount of lines, for example, or record or entries. Yeah, we barely work with them. You should not care about this, but it's just how I describe one too many into 3 smaller types, because depending on those type, we will have to make our decision later. Actually, we work with them, but we don't actually create them. That the logs are actually created by Express. So you don't have to worry too much about this. Unless you're really into DevOps, which means you have to deal with a lot of server-side stuff, Right, so here's my own tip about one-to-many relationship. Okay, I talk about the two ways, the two approaches to model out relationship in the models. Yesterday or the day before, we talked about embedding, right? Basically, I will explain more about these terms. So we have embedding and referencing. But in other words, people will also call it the normalization and normalizations. Embedding is the normalization and referencing is normalization. And what are they? So we will talk about one by one first, instead of comparing them on together. It's very confusing. I'm going to talk about embedding first and then referencing. Right. Let me ask you about relationship here first. Are you clear on this? Sorry, I jumped ahead too quickly. Do you have any question about the relationship types? Basically, we have one-to-one, one-to-many, and many-to-many. And one-to-many, we will have three smaller definitions, I would say. You may not see this term online or in any documentation, but this is how I would describe one-to-many relationship. So we use relationship for what? This is what happened in our website. Right, that's a good question. So we use relationship for what? To store our data. To store our data. You will see the relationship right away when we actually see how our data is stored, right? And right. Do we have to decide the type of one-to-many? It is. No, it doesn't matter here. This slide, it doesn't matter anything. It doesn't like have any special. It doesn't have any different special syntax or special way of structure in your model. It's just how we understand one-to-many. It's just how I understand one-to-many. Right. It's making it help you making decision later. And that's my other tips. Right, so let's jump straight into embedding the normalization. Basically, it's just a way that we will maintain on the related data. We maintain all the data in just one single document. Yeah, one single document, and that's it. Make it very easy to query or to retrieve and maintain. It's not really easy to maintain, but kind of easy to maintain. But let's see how it works here. As you see here, this is the document, a book document from yesterday, right? From yesterday. We have the ID, we have the genres, we have the title, we have the description, we have the author, we have the owner, right? Everything makes sense to you, alright? So this is how we put the related data in one single document. In one single document, we have all the information about the related data. For example, we have the content of the genres here. We have all the content of genre here, right? We have the genre name, we have the genre ID. Maybe in the future we will have whatever it is. So sorry. Let's go to another example here. We have the author as well, and we have the name. We can have the age. We can have the birth year or the birthday. We can have the gender of that author, right? So we also have the ID of that author in the collections, author collections. So this is how we embed the author document inside our book document. And here's the owner, same thing, right? So basically we have every related data in just one document. Cool. That's the idea of embedding approach, putting all data in one document. And from that, you know, now you know what's the pros and cons. The pros is the whole document can be retrieved in just one single query, like this. Book file 1 and you see everything, right? Just book file 1 and you see everything. One single query, you see everything. But there are cons. And here are the cons. The drawback is like if the documents grows in size, whenever you query the list of documents, it's like it can impact the read and write performance because the documents are too long. The data grows too much. For example, if you have one document that have 100 keys in there, and each key for like you have 10 keys that have the nested documents, that's gonna affect the JSON file a lot, the query a lot. So slow down. It's gonna slow down your query speed. By that I say impact the read and write performance, right? Another cons is that it's very difficult to update the related document. For example, if you want to update your own owner information, let's go back and see here. Okay, if for some reason I am the owner of the book and I want to change my email address, or I want to change my name, for example, I change my nickname, and I have like 100 books in my database. I have 100 books and each book will have one field like this. What if I decide to change my name, from Khoa to Khoa Dam, for example? By then I will have to change one place, which is the user collection, right? I have to find my ID and then I change the name from Khoa to Khoa Dam, and also I have to look at every single book that have the owner is me and the owner is named Khoa here. I have to change them all, which means I have to change in a lot of places, and that also slow down our performance, right? It's very hard to update. For some reason, if imagine that you are a new guy to your company, right? A new guy, a new person, a new employee, a new developer, and then you have to take care of the code, the backend code, and you have no idea where the owner information should be. Like it could be in the books, it could be in the purchasing or orders collections or renting collection. It could be in many different collections, and you have to find them all. You have to run. If you want to change just one information, you have to find in every different collections and change them all, which is not effective. It's gonna be very slow. That's the cons. Those are the cons for this approach. And then we have another approach to make those to eliminate these cons, these problems, and that's called referencing approach, or you can call it normalization. In SQL, people will like tend to call it normalization, but it's the same thing here. So referencing also exists in SQL. Actually, it's the best idea of SQL. And actually MongoDB or noSQL also take in the idea and improve their database system by using this approach as well. So the idea here is instead of storing on the object, the document, instead of storing the related documents inside one parent document, we now store only the object ID, or you can call it the reference ID. You only store the object ID. Right. How does it look in the real database, in the real data? So here how it looks. Also the same book document, but using referencing approach. As you can see here, for genre we don't store a bunch of object genres, we only store the ID of that genres. So this ID will point to the collection to to a document inside the general collections, right? Same thing for author. We don't store the whole object, we only store the ID, as well as owner. So from this you can see the browse is very compact. I will go back about this later, but there's a pro and con here. It's very compact and less bulky. Your document looks like smaller in size, less text in that. It looks less bulky, it looks more compact, and it's more consistent. What do I mean by consistent here? Consistent here, like for example, if you want to, if you decide to change the name of your owner, you only have to change it in one place. And where is that? Where is that? I just need to change my name in one place. Where is that? Can anyone answer, please? Quickly. Using the approach. What? No one answer? If I decide to change the name of another, where should I change it? User object. Yes, we change the user document in order. Yeah, almost there. I'm talking about the owner. Yes. Basically, in the user object or the owner object, right? In just one place, we only have to change where the ID is, right? Look at the user collection, find the document that have this ID and change the name. That's it. You don't have to go into every single document in the books collection to change them. So that's the pros, and there are also cons. The cons is you need to run more queries just to read the documents, right? For example, this is the same result when you do something like user.find ID, right? User.find by ID, and you have, it's not user, sorry, books.find by ID, and you see this one document, but inside this document you see nothing. You don't see any related information about the genre. You don't know the genre, what the genre is, what the author is, what the owner is. You only see the ID, right? In order to see those data, the related data, you need to run additional queries. Mongoose will do that for you behind the scene, but in practice, you also have to run 3 additional queries. For example, you have to find the ID here and stick it to the results. You also have to find the author here with the ID here and stick it here. So basically, you have to run 3 additional queries: 1, 2, 3, and 1 original query, which will get the collection, the document here. So you have to run in a total of 4 queries just to get all the information of this document, right? So that's the cons, and that will result in a very low query performance, right? Very low query performance, and it's very hard to scale horizontally. For now, you don't need to understand too much, get too familiar with this term, but basically you have to store all information in one place just to run additional query to get the related data. Right, so that explains the pros and cons, and I'm gonna go back and explaining the referencing. This is not very important, but it's good to know. For referencing, we have 3 types of referencing: the child referencing, the parents referencing, or two-way referencing. What are they? Basically, they are just for example, child referencing, you keep the ID inside your parent. Yeah, you keep the ID inside your parent. So here, user document is the parent of these books. For example, it's one to many. One user can have many books, and you keep the book IDs inside your user document. It's very like a common pattern you will see. Also for the author can write many books, right? Same thing here. You keep the ID inside the author. So you will use the ID to trace to which book is that. Same here. Book ID, book ID. Another type is the other way. Is the other way of child referencing. You call it parent referencing, meaning you keep the ID inside your children object. For example here, this is what we have yesterday, right? Instead of having ID, we have a whole object. So for a book, you have owner, you have author, and you have then you have an ID. If you take a look here, it's called child referencing. Was it? No, it's called parent referencing. Sorry, those are kind of terms very confusing. We don't really it doesn't like affect much about to our code, but it's good to know. So those are parent referencing, meaning we put the information, we put the ID inside our child here. A book is child of author, of owner, of genre somehow. And the third type is two-way referencing. This one is very complicated. Basically, we have arrays. A genre can have many books. Books can have many genres, right? So this one is very confusing. Two-way referencing. It depends on how you want to run the queries later on. For example, you want to get all the books that belong to this genre, or you want to get all the genres that belong to this book or have this book. Type like that. So we have two ways of referencing. This one is hard. You don't have to like be fixed on it, but it's okay. Good to know. So here's the main concept. Here's the main thing you need to understand. So as you can see, the pros and cons. You have two ways to do just one thing, and it's all about the trade-off. If you want to do this, you need to. If you want to, for example, you want your website to run faster, right? As fast as possible. You need to. And there are a little couple small information about. Let's go back and take a look at this. If you want to return the list of books quickly, as fast as possible, you may have to use embedding approach for genres, author and owner as well. So it's a fastest, but it's very hard to edit later on. So it's all about trade-off. And there's no right or wrong here. There's no absolute right or wrong. In SQL, yes, you only have one way to do it, but in MongoDB or noSQL, you have two ways to do the same thing, and that's why so many people hate it. For example, Charles really hates MongoDB because like he has to make decision every time he wants to define a model. Embedding is an idea for scaling either, because what's the point of making the database big when it's being so hard? Oh, one good thing about MongoDB is like actually MongoDB is very good at scaling in size. Horizontally means size inside. And if you put every information in just one object, right? Yes, your database is gonna get bigger and bigger, but it's very easy to query. Like I said before, you only want run one query and you have everything. Yes, but it's very hard to to modify the data in there, and that's why we have to think carefully before we design our model. There's absolutely no right or wrong here. It depends on the nature of your app. For example, we will have a couple of reasons or a couple of tips in order to define the model, or choose which relationship you want to use or which approach you want to use. And here are my tips. Right, before making a decision, you have to think about these three factors. So these are the three factors when you're making when you make a decision whether to choose embedding or whether to choose referencing. Run, like you can see the full object in those. So yeah, it's slow because we have to run 3 additional queries. It means 4 in total, in referencing approach. But in embedding approach, you just run one query only. Right. Alright, how about let's imagine if we want to return a list of books, and then for each book you have to run 3 additional queries. You have a list of 100 books, so you're gonna run like 300 additional queries just to see all the information of the 100 books, right? Comparing to embedding approach, you just run 100 query and you will see 100, not really 100 query. Oh shit, I got a number wrong, but kind of like I'm gonna type it here. One query to see all information, see all the books with related data, right? And using referencing approach, you have to run one query for them, one original query, plus 300 additional query. So it means it's kind of like 301. So that's a bit different, right? As you can see. So it depends. It's all depend on the nature of your app that you make the decisions. So first thing first, you have to look at the relationship type and see how closely they are related to each other. This time I already have everything. For example, for one-to-one, most of the time you want to use embedding one-to-one. You want to use embedding approach somehow, yeah. And then decide, and many to many, you have to use. Of course, you have to use referencing approach. For example, you have one to a few. You can use embedding approach. For example, one book can have a couple of genres, right? You can use embedding approach there. You can embed all the object inside just one book. It's easier to query, and you hardly that when we move to the next question, how often the data is read and written, is read and written. So it means the read and write ratio. For example, if you have a book and then in that book you have a couple of genres, the name the genres you hardly change them, right? The names of the genre, like in a year you hardly change them. For the genre fiction, genre science, you hardly change them. They're just there. You create them and then just put them there. You hardly change them. Comparing to the address, you may have to change the address, yes, but you hardly change those kind of information. For example, the genre name, you would never like to go change from science to romance, for example. You just create a new genre. That's it. So it also depends on how often your data is read and written. The third factor is the closeness of the data and how we want to query them. For example, if you want to show all the books, let's make another example. This one is right. So if you want to show all the books that belong to this genre, you have a couple of ways to do it. For example, you can find the document inside the books collection. That's one way. But you also have you can also use the relationship to find it in the genre collections. If you have if you define the relationship in your genre collection, I will show you later in the lab. So you have to answer these 3 questions before making the decision. Doesn't have to be on 3. You can go in order here. The type first and the how often your data is read and write. This one is very important. I will make an example in next slide. Right. So here's my general tips. You should use embedding when the data is mostly static, meaning you hardly change it. For example, genre names, right? You can see the image here. Each movie, for example, take an example at the movie database. The movie database. The application the React app, the movie database clone, right? You read you use the API from the movie database.org. So basically, each movie will have a bunch of images, and you hardly change them. They are static, right? There are many of images in just one movies, but we hardly change them, and we hardly call them individually. Like we only show the image when we show that movies. We don't really care about the image at all. And data does not change quickly or frequently. Yes, these two. And it has a very high read and write ratio. What do I mean? Read and write ratio. For example, you take a look at the read and write ratio. For example, take a look at YouTube. For example, YouTube, you have one video which has a million views, but only 10 comments. Those kind of figures are read and write. For example, you have 10 million view, 1 million view, or 10 million view, but you only update the information inside that document only 10 times or 100 times per 1 million views, 1 million reads. You write only 10 or 100 times. So that is a very high ratio, read and write ratio. And you have to look at how they really belong to each other. For example, if you have a user have a couple of addresses here in your database, and each address only belongs to one user, to that one user, and the address doesn't mean anything. It doesn't mean anything. If you want to get like if you have that address and you have no information about the user for that address, it doesn't mean anything for you, for the one who have that clear data, unless you have some special purpose. For example, you can find on the addresses that's very close to that points of locations. If you want to do that, you need to use a different collection to store all the addresses, and then you make a reference relationship to the user collections. So right now it's very hard to imagine what's going on the database, but just do a couple of exercise or a couple of projects, and then you understand more and more. We learn by doing. Right? So don't expect to understand everything now. We learn by doing. The more we do, the more we can understand these. So when should we use referencing approach? When should we use it? We should use when the data is updated a lot, right? The data is updated a lot. For example, the like 1 million view, and you have like a couple of thousand like, for example, right? So people tend to watch the video and click the like button a lot, or when they like it or they unlike it, or they change the icon. For example, Facebook, they like your post, they haha your post, they laugh at your post. Those are also data, and those data are updated a lot. It has low read and write ratio. For example, 100 people view your video and 10 or 20 of them like your video or comment on your videos. So that's a very low read and write ratios. And we also frequently need to query the data set on their own. What do I mean by that? Each movie can have a lot of reviews or comments. For example, each video can have a lot of comments, right? And each comment will have on data. For example, the one who commented, the content of the comment, and the time or the rating as well. So those information can be updated quite frequently. For example, I comment on that, and for example, the next day I come back, I decide to change the content of the command, for example. So these kind of actions are very like frequent. Another example is like yeah, I already gave an example. It's very like frequent to receive an upvote or downvote by a user. For example, if you go to Stack Exchange, Stack Overflow Exchange, you will see this guy ask this question, and then another guy answer that question, and he received a bunch of upvote or downvote. I personally, when I receive read an answer or a solution, I usually click on upvote, right? So kind of like give the answer, the one who answer, some spirit, some encouragement, and you should do that too. So basically here how you decide between embedding and referencing. So these are just my personal tips. So for example, question. So for example, movie movie DB, both embedding and referencing are good. Oh, when we talk about two approaches, doesn't mean we have to use either one of them. It doesn't mean we have to be fixed on embedding approach for the whole database or referencing approach for the whole database. It varies from collection to collection or model to model. For example, you may want embedding approach for genres, book and genres, but you want to use referencing approach for books and honor, right? Why? Because the honor data is frequently changed. If you take a look at here, the data of honor is frequently changed. I don't know how often you change your name or change your biography, for example. Many people tend to change a lot, and that is the reason why we need to use referencing approach for the honor. Cool. But for genres here, we hardly change anything about the genre name or sample. We just create the genres and then we put it there. If we want to go with another genre, we create another genre. For example, science, romance, fiction. And that is when we use embedding approach. Yes, it should be like that. There are at least 3 factors we need to talk about. Okay, yeah. So those kind of factors we need to think about when we decide making this decision here. There's no absolutely right or wrong, right? No right or wrong here. It's just that if you choose a bad approach or an inappropriate approach, it will result in your database run very slow. Your query, your request will be like very slow to handle the request. It takes much longer to return a list of books comparing to embedding approach. It's very fast because all the information is there already. You don't have to do additional queries to get all the information. But it's hard to modify information. So it's about trade-off. Will we have to use all approach for today's lab? Basically, we have to use both approach for every project. Actually, there's no fix here, but in some situation you have to use reference. Yes. For example, I'm gonna take example here. For example, take a look at this one, genres, right? Genre and books here. We should not put the books array in the genre here because we don't know how many books there will be in the future for just one genre, right? We don't know yet. So we should not use referencing approach, or even we should put a relationship here. We should not, or we would never put the embedding approach here, embedding document here. We should never embed document here. Why? Because it's gonna be like very long. This array is going to be very long, and we don't want to hold all information about those kind of books in the genre collections, right? Instead, we're gonna do something like this. We can have the genre ID inside the genre arrays here. It's good, it's okay. Or even better, we can use the genre object here, embedding. We can embed this genre object here. So it will result much faster, how do you say, query when you read a document here, right? So it's all about the speed, all about the speed. So do SQL app run on run slow because they cannot do SQL app can also use no, they cannot use embedding across because they have column and rows. There's no object inside an array like this. They cannot use object inside an array like this. And normally SQL for general purpose, it's a balance between read and write. And SQL, noSQL here, MongoDB or noSQL here are very fast, super fast on the reading speed. It's very fast because it has embedding approach here, right? So bottom line, there is no right or wrong. There is no right or wrong. Depending on what you choose, the speed of your database will greatly vary, right? All right. So time for questions. Time for questions. Time for questions. No. This is something you have to taste for yourself in order to have your own experience or your own conclusions. Is it right? Is it just right? Oh, this question from Bao. Is it just right for large database because we're working on small database and expect to know? When you work on a project, okay, this kind of question is right on the spot. Yeah, you kind of actually when you work for a company, right? You work for a company, you have to think about how big your application will get, right? How big it will get, and how many years gonna be, right? But for the back end, point of view, especially for people who design the models, they will have to think far ahead. They cannot just make the app just work in just 1 month. Doesn't make any sense. You have to go back and change everything in the next month. It doesn't work like that. You have to think like your app needs to work for at least a couple of years, right? So we have to foresee every troubles. If you decide to make it so fast and so convenient, you have everything in just one place, for example using embedding approach, and later on, what if the user decide to change the information in your code? You have to handle a lot. You have to find on those collections that have that piece of information and have you change them. So that means you have to do a lot of work in your own code. But using referencing approach, you don't have to worry all about it. Yeah, but it's gonna slow down your reading speed. So I think it's good to think about how big your project, your application, the database will get. That's correct question, Bao. Good question. But for small project, it's safest if you use referencing approach. for a small project. For a small project, it's the best bet if you go with referencing approach. So it doesn't matter if your speed is slow when you read a lot, right? Testing will be easier with referencing, yes. What do you mean testing? Yeah, if you decide to change something and you test it, yeah, it's faster. Actually, it's faster. Changing stuff will be faster. And if your application get a lot bigger, for example, in just one document here, in the book document here, you will have like 10 more fields which have reference. And if your app gets so big and you still use referencing approach for every field here, it's gonna slow the hell down your database. So your database has to handle a lot more queries just to render the books, right? So that is when you decide, okay, this kind of information, we hardly change it, we hardly modify the data, so we might use embedding. Also, the author, like, they should never change the name, right? The author on the book, if you look at the book itself, on the book, you hardly change the name of the author, right? So you can use embedding approach there as well. And lastly, the owner here can be the renter or the owner or the renter, and they tend to change the information. For example, they tend to change the nickname, they tend to change the email, they tend to change their address. Those kind of information, they tend to change a lot. So you may want to use reference. So on average, SQL app runs slower. That's why. No, it depends on the query. It depends on the queries, but mostly it reads slower. The speed for the reading operation read slower, but it's write SQL write much faster. Normally it's write much faster, but it reads slower. Right, questions? So for small projects, to keep it simple, you can use referencing approach. Keep it simple. And then when your app get bigger, you may think about embedding. Okay, any other questions before I close it? It's 11:20 already. Right, then no questions. I'm gonna stop now. This topic is very interesting, and you can read more on the internet or do more research, and there are absolutely no right or wrong. But they're kind of like, you should do that, you should not do that, but there's, you must do this, you must not do this. There's no way. Right, and it's all depend on your purpose, your application logic. Right, so that's it. I'm gonna see you in the afternoon for the walkthrough. In the meantime, you can keep working on your yesterday project, or you can take a look at the project here. These are very similar to you, right? Set up the model, but here today we will learn how to set up the model using referencing approach, right? Okay, see you guys later.